रिकॉर्डिंग कर रही है।
Hello, good morning, folks. Can you hear me?
Yes.
Hello?
Yes, thank you.
Can you hear me?
Hi, good morning.
Good morning. Very good morning.
Good morning, sir. Yes, we can hear you.
Okay, so my colleague is joining in few minutes, but let's do a recap. Okay, so we started with the Hadoop installation. All right, and we were going through different files in the Hadoop installation. Right, we have finished the configuration of the files. Now, what we have here, let me share the screen. Can all of you see my screen? Can you see my screen, all of you?
Yep.
Just a second, please. Hey, Santosh. Oh, no. Username would be. One second. No, any name is fine. Username. Yeah. Yeah, you're in. You're in, right? Okay. So I think you're not in yet, but you're about to begin. Santosh. Okay.
Okay.
Okay, let me complete what I'm doing and then I'll go to it.
Sure.
Okay. So, alright, guys. So, let me run through this one more time. So, we have seen that Hadoop installation, right? So, what we said is it has some prerequisites, right? So, in this document that we have given a very precise instruction so that you can go through it step by step so that you don't miss it. So we need Ubuntu. It could be any release, but here we recommend 12.04, and the link is also mentioned here. We use Hadoop 0.20.2. This is the most popular one. Lots of people use it, and the most stable one. So just for the start, we don't want to get into it, so we recommend this. So the link is also given here. And then the JVM, you can use JDK 1.6 or 1.7. Whereas here we have given you JDK 7 downloads exact link where you can download, right? So whatever steps that comes after that is sequential. You do one after the other, you should be able to install Hadoop. There should not be an issue. So I will change the presenter to my colleague Santosh. So he's going to walk through the rest of the document. Okay, Santosh?
Yes, sir.
Yeah, go ahead. I think you can open that document and then start from SSH.
Yeah, sure. Thank you. Hello, everyone. Good morning. This is Santosh here. Today I'm gonna I'm gonna show you how exactly we're gonna install Hadoop. Okay. Yes. Okay. As initially, you will install all the request software, right? Ubuntu Linux, and then Hadoop, and then JVM. And then once you do that, then we'll go ahead and create a separate user, like as we are doing it here. Like we have, initially we'll create a group named Hadoop, and then we'll go ahead and create a user named Lakshman, a dedicated user for Hadoop. We are not going to install anything apart from Hadoop on this particular user. So, and once we do that, we are going to configure SSH. That is nothing but secure shell. Why we are doing this is because Hadoop works in a cluster mode where multi-nodes, two nodes, that two hosts, okay, two machines need to ping each other, okay, they need to communicate. So what we need to
hello,
do is, yes.
We are getting disturbance.
Can you hear me now?
Still there is disturbance.
Yes. Can you hear me now?
Yes.
Hello.
There is some back noise actually. Background noise.
I can hear that from your side because whenever you speak, it's like repeating, like echoing. So, I mean, does anybody has the same noise? I mean, can everyone hear me?
Yeah, there is background some kind of a noise, definitely, yes.
Okay. So, I mean, is it okay now?
Yes.
Okay. Okay, then fine.
Yeah, it's good now.
Okay. So here we are gonna install SSH. So the two hosts they can communicate with each other with with a passwordless login, I can say. So, whenever I try to communicate another node, okay, it doesn't ask me any password. So for that we require to configure SSH on the nodes. So in order to install it, we have a command named sudo apt-get apt-get install SSH, and this is sudo apt-get install rsync. Rsync is nothing but it synchronizes all the files and folders. So that's why we use this. Okay, and we switch to the user Lakshman here, and then we are generating a SSH key. It's public key or private key, and then once we generate, once we give this command, it generates a key. Okay. So after generating the key, we are copying that public key into our authorized keys. So there is a command you can see here. Okay, and after copying those keys, that key, then once you type SSH localhost, you should be able to see the same message. It asks for yes. Then after typing in as, you should be able to see the message saying that it's done. And now your SSH, and you will be able to communicate with the other host without any password. That's what SSH does. And next step let's move into the installation. And in installation, let's log in as Lakshman. With the username Lakshman. Since we are using this particular user as a as a dedicated user only for Hadoop. Okay, so let's create a folder named Hadoop in this particular location. That's let's change the directory to user local, and here let's create a file. Name Hadoop. Okay, user local, and at this particular place we are going to install Hadoop 0.20.2. We can once we download the tar file, we can unzip it by using this command. Okay, and then we are moving this particular Hadoop to the Hadoop directory, that is, and we are giving the permissions, the complete permissions. For this folder, that's full rights. Okay, we did install Hadoop in user local Hadoop. That's where exactly our Hadoop directory is placed, located now. Okay, and then we have, this is nothing but setting up the bash RC files. That's let's open in our editor. That's how we open by using the command vi /.bashrc, where we set all the home, all the variables like this, like Hadoop home, Java home, and we'll give the path, so that all the and here you can see we are even setting up the Hadoop environment variables. That's Hadoop. See, this is what we're doing. That's we'll set up the Java home environment variable. So these are the this is nothing but bash RC, and this is nothing but the Hadoop environment env.sh. Okay, these are the two. We need to export Hadoop home, Java home path, and then Hadoop home. This is in order, like whenever we are trying to install, we get a message saying that Hadoop is deprecated. So to avoid that, we use this Hadoop home one suppress equal to true. We'll make this as true so that we don't get that message again and again. And then later we have this configuration files. We have 4 configuration files. One is config site.xml, hdfs site.xml, maprate site.xml, and the other one is core site.xml, where core site.xml, what it does is it specifies all the parameters which are relevant to Hadoop daemons and clients. Okay, and these are configuration which you can see. You need to open this. In a particular, in our editor, VI editor, just type in VI conf core site.xml. Core site.xml in this particular location. Okay, enter into Hadoop. And once you're in Hadoop, enter, go into the directory, that's configuration directory. In configuration directory, type in vi core site.xml. That once you're into this particular file, just copy and paste this particular file. Okay. Once you copy and paste this, that's it. You should be able to specify all the parameters which are relevant to Hadoop daemons and clients. That configuration file does. That's an XML file does. And the other file which you have here is configuration maprate site.xml, and this also specifies parameters that are used by Hadoop daemons and clients. Okay, so you need to type in that's the same thing like vi maprate site.xml in the configuration now folder. Once you're into the configuration folder, and then directory, and then copy and paste this. And the other one which we have here is configuration hdfs site.xml. That is this specific XML file specifies what are the parameters that are used for map reduced, used by this map reduce daemons and clients. So the same thing, open this hdfs site.xml and then copy paste this particular part. Okay, does anybody have any questions till now?
Hi Santosh, Vaibhav here.
Yes.
Santosh, actually the link which we have for downloading Hadoop,
okay.
there I cannot see the version 0.20 point something. The versions which are there are starting from 1 dot or 2 dot.
Okay, just give me a minute. I'll exactly show you how exactly you need to proceed. Okay, I open it, I get this.
Okay.
See, just click on download, okay, and then click on download a release now. And then just click any one of these, okay, mirrors, and then go to any of these versions, like we have 0, 2, 0, 3, this one, and else go to older release which are available, and then here you can find all the releases. So select one of these and then download.
Yeah, that's
okay.
Yeah, I get it. Yeah, thank you.
Okay, thank you. Okay, once we are done with the configuration file settings, once we make sure that all the files are in its proper once all the files are configuration files are set, what we are going to do is next we are going to format the name node. I mean, we have a name node, secondary name node, job tracker, task tracker, right? So now we are going to format the name node, and here is a command, and you can see this is the path where exactly our Hadoop is installed. Okay, user local Hadoop, and then we are into bin Hadoop name node format. So this formats the name node, and you can see this is how the process does. This is what the output is once you type in the command. Okay, and then next.
Santosh, one question.
Yes.
The 4 configuration files that you mentioned before, the values in it, the property values, is it, how do we decide in a real production environment, who is it, like constant values, or they're going to change?
I mean, what exactly we are gonna, like, for MapRed, we are gonna give the replication value, like we have, just give.
What the default value, for example, you have replication value as 1, right?
Yes.
How do we?
No, replication value will make it as 2, okay, or 3, because it depends upon how exactly we keep.
Okay. So each file has parameters that needs to be modified according to the specification given by the company, I guess, right?
Yes. It depends upon our own, how exactly, our environment we can give it. There's no specification.
Yeah, folks, I am ready. I will take this question. See, generally, depending upon the requirement, you set the replication factor. For testing purposes, we are putting here as 1 because we don't have a lot of hard disk space. Generally, in production, the value is 3. And for more secured and more reliable environments, they can increase the replication factor by another 2, maybe 5 copies or something like that. But generally, in many of these IT environments, they put 3 as the replication factor. Subsequently, when we discuss the configuration in detail, so this is just the installation document, which allows you to install in step by step. Each of these properties we are going to go in detail, because as an administrator you would be knowing the inside out of the properties that we're going to discuss. So just to get a preview, we're going to discuss how we're going to configure Hadoop file system parameters. We're also going to discuss at a great length how we're going to configure the MapReduce parameters. So in that time you will see exactly what parameters is used for what, and how do you control different aspects of this configuration. Okay.
Yeah, very good. Thank you.
Yes. After formatting the name node, here let's start configuring our single node cluster. Here is a command to start all the process. Once you type in this command bin start all.sh, here are the process which to start. We have task tracker, job tracker, data node, secondary name node, and the name node, and Java process. So these are the, you can find out like which are the tasks which have been started by typing this command JPS. Once you type this command after this, bin start all.sh, you will be able to see the tasks which have been started. In case if there's something missing like name node, you can't see a particular task. You see this task, it means that this particular name node has not been started. So we need to find out what exactly went wrong, and then redo it. Try to start it again, or check the log files, like where exactly the problem is occurred, and then these are the things, these are the tasks which needs to be which needs to be on. And then there's to stop all the process, we do have a command that's bin stop hyphen all.sh, which stops all the tasks. Okay, you can see here there's the stop all.sh. Okay, So I'll just show you how exactly, how exactly you copy a file from our local, from our local system into the Hadoop database. Initially, we need to have an empty file or any temporary file within our local system. Okay. So you see, use the local Hadoop. This is where my Hadoop files are, and the ones you type in, and these are the commands which we have in here. Okay. So this is my local system. Okay, I'm trying to. Okay, let me create a just plain simple text file. Okay, it's nothing but testing.txt. Hi, how are you? Let me just type in okay. Let me save it and close it. So we have testing.txt file which on our local system, and this one I'm copying into our HDFS, that's not what our Hadoop file system. Okay. So further, I'm going to use a command which we have here. You see, this is a create a text file, any text file, and save the file. Okay. And then now copy the file into the TFS by using the following command. You can see the command here. So this is the command. Okay. So I copy it in our home Hadoop. Sure, it's it. My testing file is in this particular location. That's nothing but home Hadoop desktop testing.txt. So I'm copying into this location. Sorry, just give me a second. Before that, I'll just show you initially I'll stop all the command, all the tasks. Okay, no job. Stop. So all the problems, you can see all the tasks which have started: name node, data node, job tracker, task tracker, and the secondary name node. Everything is up. So now what I'm going to do is I'm going to copy the file. To any location. Okay, we have user test folder. Let me create test zeros. test zero. Okay, and trying to copy this file into our Hadoop test zero. Okay, and you can view the files in our DFS by this command bin hadoop -ls then root user. Sorry, DFS. Okay, see, you can see this test zero. Yes, now you can see the text. So this is the command which we use to copy a file from our local file to the TFS, and this is a command to list the files within our TFS. Okay. So in order to run a map reduce job, like in order to run, say, let's run a map reduce job named word count. Okay, here we have a file named as test data. Okay, and we are trying to run that data in that particular file. Okay, and produce output in test data output. Oops. Just wait a second.
Okay, I'm ready here. Just one question for you guys. Did Ashok talk to you about the word count program?
Yes.
Yes.
Oh, he did. Okay. All right. So what we're trying to do here is a couple of things. Santosh, can you show the browser?
Yes. Okay.
So what we did simply is a couple of things, right? We installed the prerequisites, we configured the SSH, and we started Hadoop, and then we're looking at how we can work with Hadoop. So before we do the commands, we wanted to show you the browser interface for these daemons. Okay, he's going to show you those browser interfaces. Okay, so this one, if you see the name node and the task tracker, so the name node is available at this location, localhost 5000, 50070 port, right? So this is okay. Santosh, keep it at name node.
Yes.
Okay.
Yes, sir. Yes, sir.
Okay. So here you see that the name node is started. Name node, as you know, is the master or the supervisor for the whole storage system in Hadoop cluster, and it is the only one copy that is available. And if you see further down, you can see that what version of name node is running, and then there are no upgrades in progress. And if you see the cluster summary, you could see there are how many files and directories are there, how many total blocks are there. So again, this concept concept is very important for you folks. The file itself is no longer intact. The file is split into blocks. So the file is chopped into blocks, okay? And only the blocks are stored, and the blocks are stored in different nodes in the cluster, okay? And that is how it is. So that's what it's saying. Total there were about 506, 191 blocks equal to 506 total. I'm not sure what it is. We'll try to find out that. Then there is a heap size. This is the JVM heap size. Now you can also see the configured capacity, how much of it is used, right? How much of it is remaining in terms of percentages. And what is important in this is that you can see that there is a live nodes, right? Can you click live nodes, Santosh, once?
Sorry.
Yeah. So if you click the live nodes, there is only one node. It says one node, and it is nothing but that currently we are running the server in a pseudo distributed mode, which means all the daemons are running in the same machine, and you would see only one machine in this list. And you can see that the node name is Ubuntu. Its last contacted was just immediate. It was just right now. It was contacted last, and the state of that is it is in service. It has this capacity that is being configured, and so much has been used. So non-DFS used. Non-DFS meaning basically the hard disk is used for other purposes other than storing the distributed files. Okay, this is the remaining. And you can see there were about 191 blocks. Now can you go back?
Yes.
Okay. So if you come down here, come down. Yeah. So here you would see that there is something called user local Hadoop data name node, which is the storage directory, right? This is what we configured in hdfs-site.xml, right? So it shows that where you want to store the name node information, So can you go and say ls into this directory, Santosh?
Yes, sir.
Go to terminal and say ls
Yes, sir,
user
yes.
local Hadoop data name node.
Okay. Sir. Yes, sir.
Yeah, so just say ls current, cd current, and say ls. ls. Okay, say ls minus al. So as administrators, right, the one thing that you will be protecting throughout the life of the cluster is fsimage. You see there is a file called fsimage. So this file consists of the information about all the files in the cluster. So when a file is copied to the cluster, the entry of that file is in fsimage. Just the entry, it is not having the contents. The contents are actually in the data node as blocks. We will show you in a minute where those blocks are located. So what is the significance of this fsimage? So the fsimage, this is an interview question again. Generally, you will run name node in one machine, and the size of the file system is determined by the size of the fsimage. And remember, the whole fsimage is loaded in memory, and this is when the name node starts, this fsimage is copied into the memory, and the name node does not work with the disk anymore. It works with the memory copy. It keeps updating the in-memory copy, right? So what happens is, if you create a file and its entry is in the memory, right, and before it is saved to the disk, if the name node goes down, then the information about the file is lost. So in order to avoid that, what name node does is it creates that entry in edits file. It creates that entry in edits file along with the in-memory copy. So you might ask me, if it is creating another file, why not save it to the disk? It is not so easy to save, to 15 to 20 GB of file to the disk immediately, because the whole file, if you have to save it, it's going to take a lot of time. The FS image is going to grow big depending on the size of the cluster. So instead, whatever changes that are happening to the file system are saved directly in the memory, and only those incremental changes are saved in the edits file. You see, there is a file called edits. So that is the file where the incremental changes are stored. So once in a while what happens? The FS image and edits have to be merged. And in order to do this, if name node is quite busy in the cluster, because name node has to answer all the queries related to files in the file system. So if we have a 200 node cluster or a 500 node cluster, the name node is quite busy answering all these nodes in the cluster, talking to data nodes, talking to the clients. So name node is quite busy. So in order to help the name node, there is a secondary name node. So the secondary name node is not a backup, as we discussed earlier. The secondary name node is basically helping to function name node more faster. So what it does? So periodically, secondary name node will get a copy of FS image from the name node. It will get a copy of edits. It will merge it and then inform the name node that it has merged everything and take the new copy. So that is the time where the name node will take the new copy from the secondary name node, and it will remove the old edits and start creating the new edit file. So that is how it works. Is it clear? This is very important, and we will touch upon this several times as we move forward. But the concept as an administrator is very important. So when we discuss about the high availability, right? So the name node and secondary name node are going to run in the same machine. When we discuss about the high availability of the Hadoop cluster, we are going to have one more name node server which will be having a copy of this FS image and edit files. So when we discuss the name node high availability, we will be having one more name node server which will manage this FS image. So if one of the server goes down, automatically the other server will be able to launch the name node and look at the same image file. So that is the whole purpose. Okay, so we will discuss that more subsequently, because as an administrator, this is going to be the primary task.
Excuse me.
Yes.
Excuse me. Could you explain this once again, because I am confused. Because what we discussed in the last class was first the log, FS image and edit are updated in the primary node, and then later on it is updated in the secondary name node.
No. So let me repeat again. Let's say as a user, I want to create a file or copy a file into cluster. So first I have to talk to name node. So name node will give me the information about this file, where I have to locate this file. So it says, okay, go and put this file in a data node. Okay. So then I go and put the file in the data node. So the information about the file is in the FS image. It's an in-memory copy. Okay. Even though we are seeing it in file system, when I create a new file, that new file entry is not there in the disk. It is there in the in-memory copy. Okay. But there is another file called edits. This new file, information about this new file is also copied to edits file. So this is all done by the name node. It is the master server. It is all done by the name node. So again, the copy of the file, the information about the file is in the in-memory of name node, which is nothing but the in-memory copy of the FS image. It is not in the disk. But what is it in the disk is the same entry is there in edit file. The same entry is there in the edits file. Now the question was, right, periodically we need to merge these two, FS image and edit file. So what the secondary name node does is, it takes a copy of FS image from the name node, it takes the copy of edits and then merges them and then gives them gives the name node a new copy. That's what it does. Is it clear?
Yeah.
Okay. So again, the reason why this is done is that if you have to checkpoint, if you have to save FS image periodically, it's quite an expensive task. And besides, the name node is a very busy server. It's a very busy process because it has to service the data nodes and also the various different clients that are using the cluster. Okay. Just a second, please. So let's move on. So Santosh, can you show the directory of the data node?
Okay.
One quick question.
A quick question,
Image and edits, are they binary files or they are readable files?
You cannot read them. It is in the format which the name node and secondary name node understands. But they are files. They are not binary files. They are text files.
Hi Vijay, I had to ask one question. What does FS image have? Does it have the metadata or the actual file that we are trying to save?
That's correct. That is correct.
So if I'm having a cluster of 20 GB, so FS image will be also of 20 GB?
Yes, that is true. Cluster of 20 GB. No, wait a second. It is not the content. It is not the content is not here. Remember, only the information about the files are here. See, for example, I'm trying to give you an analogy here. If I have a vehicle registered with government, if I have a vehicle or a car registered, my address, nameplate is there with the government. That is the metadata about the vehicle. The vehicle itself is not there with them. The vehicle is with me at my house. Similarly, name node maintains the metadata of the file. The address of the file, where is it located, which data node it is located, how many blocks are there, what is the replication factor. That is the information that FS image has. It does not have the data itself. Where is the data? Data is there in the data node. So that is what Santosh is trying to show. He's done a LS. If you see the screen, actually, you will see different blocks here, right? Those blocks are not the content of the files that are there in the cluster. Now, so if it is divided into blocks, who will take care of assembling all this together? Who will take care of assembling all this together? Who knows that all these blocks are put together, you get a file? Only name node knows it. Data node job is just a slave. It says that, okay, you take these 20 blocks and you save it. That's about your job. Don't worry about which block belongs to whom. That's not the job of the data node. Data node job is to just save the blocks. That's all it does. Whereas the information about the file itself is there in the name node. So that is FS image. Is it clear?
I have one more question. So secondary name node also serve as a backup or not?
No, secondary name node is a helper to name node. It is not a backup. So if name node goes down, the cluster will go down. Nobody is going to help you.
So there is no backup for the name node?
In this current installation that what Santosh is showing, yes, there is no redundancy or there is no backup for name node. When we discuss the name node high availability later, you will know how to make sure that name node is backed up. How to make sure even if one process name node goes down in one machine, you will have another name node which just gets started and then still serve the cluster file system. We have not discussed that. We will discuss in the subsequent classes.
Okay. Thank you.
So is it clear?
Yes.
Yes.
Okay, good. So we have shown that you can browse the file system, cluster file system using the browser. So Santosh, can you go and show the browser?
Yes.
So you can actually go back and say browse the file system. No, file system only. Name node.
Okay. Okay.
No, not here. Go to browser. Go to browser.
Yeah. Just yes.
And then go up little bit, and then say browse the file system. Yeah, browse the file system. So here you would see that it is like a ls in a directory. You would see the directories, subdirectories, right? And you will also see here what is the type of the file and how much is the size, what is the replication, what is the block size, what is the modification time, what is the permission, who is the owner, and what is the group. So the permissions are purely driven by the Unix permissions. So the owner and the group permissions with RWX, read, write, execute permissions that are set here. So this is like your explorer looking at the explorer and say what are the contents of the directory. So for example, I can click user and go to a user directory. So and here I think Santosh has shown that you can copy a file into cluster file system using a command. We'll go over the command one more time, and if you click on test 0, you will see that whatever file that he has created, you can see that. Hey, how are you? This is the test file. Again, as an administrator, you will not be giving permissions to see this file. Only the owner can see the file. Since it is a single node, we are trying to be a super user and try to do everything ourselves. So when we discuss a little bit about security, we will discuss how to protect so that other users will not see the files that are owned by other users in the system. Okay, so now I hope it is clear about Hadoop file system, Hadoop cluster. Now we will go to the command line, and we will discuss how to copy a file into the cluster. So that command is already given by Santosh, but we will go one more time.
Yes.
So can you go one more time, Santosh?
Yeah, sure.
So the Hadoop, go back to that. Hadoop provides you lots of commands.
Yes.
To query the file system. Yeah. Which directory structure? Can you, which directory? Yeah, it can be because you configured it in a different folder, right? Right, so we'll discuss that. So the thing is that, let me take control. Okay, 1 second. So this is a good question. So all of you see my screen. Okay. So we discussed that all the configuration files will be in this directory, hadoop 0.202.conf. Right? If it is 1.1, it will be hadoop -1.1.2/conf. So if you open hdfs-site.xml, correct? So we discussed about explore these three properties very clearly at a greater length. And in fact, we're going to discuss it one more time or a couple of more times, because this is, as an administrator, we need to know exactly where these files are. For example, here you see I have a configuration tag that I have three properties. One property says what is the replication factor for the whole file system. Again, this is by default. You can also change it at the time of creation of the file. It is not necessary. By default, if you don't give a value, this value is taken. But at the time of creating the file, you can pass a parameter. What is the replication factor? That replication factor will be taken into account. Now the second property is the dfs.name.directory. This is the directory what Santosh was showing. User local Hadoop data name node. Now if you don't have this property in your configuration file, by default Hadoop will pick up a temp directory. That happened in your case. Okay, so whatever directory you give here is the directory where the name node files are stored. Generally this value is comma separated directories, because if it is comma separated directories, as you see here, same file, the FS image copying two different locations. When we availability this again, generally this is comma separated values, and you would see that these two are different paths, and these are different paths for a reason, because they are in different disks, and generally one of them is NFS mounted file system path. This is to make sure that FS image is protected, because we know that if FS image gets corrupted or FS image gets lost, then the whole file system is lost. So that is a very dangerous thing. Hence, we try to protect it as much as you can. So in your case, if you don't specify this directory in the HDFS configuration file, it will automatically pick up a temp directory. That is what happened. Okay. Similarly, in a data node, this is the directory where you will see the data node. This can also be comma separated values, comma separated path values. In such a case, the data node will copy the files in a round robin fashion at these different disks. Okay, it is slightly different from name node. In name node, you will see the same copy in different paths, whereas here in data node, you will see blocks being copied in a round robin fashion at different disks. So block 1 could be in path 1 and block 2 could be in path 2. Again, when we discuss the Hadoop cluster configuration in a very detailed manner, we will see that time we will delve into these issues, this configuration one more time at a greater depth. So does that answer your question? Yes. So basically, it means that when you want to make sure that you protect FS image, we are having a backup plan. The backup plan is, don't just put the file in one place, put it in 3 places. So where are those 3 places? That is nothing but the comma separated values. Is it clear? It will pick all the 3 places and put the file in all the 3 places. Okay, so when a client has asked the query, name node response, and that will be the path of the very first file. The other files are just a backup in the name node. If the first is down, then the name node is down. So you have to have a name node, another server, which will pick up the same copy from the mount, from the NFS mount, and then start the cluster. Remember, this is just a copy. It is like your certificates are xeroxed and put it into your locker. Okay, you are putting the FS image in a locker called NFS disk file, NFS disk. Only this is used as a backup. Let's say that this file is corrupted. I can copy that file from the NFS to my local directory and restart the name node. Okay. Yes, all the three files, So it is the job of the secondary name node. So the name node is not going to worry about this merging. The secondary name node is there because it can help the name node. Okay. Okay. This is just to discuss because you guys are able to understand this. Okay. Now going back to the end. So Santosh, you can take control. So he is going to show you some more commands. So there are about 30 to 50 different commands you can work with the Hadoop file system cluster. So what I suggest by next class is that you have your Hadoop installed, and if any of you have any questions, we will answer them. And how do you debug in that case, right? If you have any issue about the starting, right, there is a logs directory in the Hadoop home, logs directory under Hadoop home. You go to that Hadoop home and cd logs, you will see the logs directory, right? Santosh, you can show that.
Yes.
So you can go to cd logs and you can see that every process has a log file. They are also dated. They are also tagged with a date. The latest one is the one without the date. So you can open this file and figure out what is happening with that particular process. Okay, so that is how you should be able to debug. And in fact, you will be looking at this file, this logs directory more frequently as an administrator. Okay, so let's copy some commands. Let's do some commands. So can you do ls using command line?
Yes, sir.
Yes. Yeah. No, keep it with what you have installed. That is fine. Everything is going to be same. Keep it. Okay. Okay, let's move on. So this is the command to show the listing of the files in the root directory. So you would see, so just like in went to browser and saw the different directories in the browser, this is the command line version of the same thing. You can do bin hadoop fs or dfs and ls, and you can see the directories. So you can also cat a file. For example, you can say bin hadoop dfs minus cat / user class test0. So the file that you created a while ago, you can see this file. Generally, do not try to do this, because we know that most of the time See here in our test system we have 2 line file, right? So you can see that using a cat. But suppose you do a cat of a terabyte file, what happens? For half an hour to 1 hour, you will see, not even 1 hour, maybe a whole day, you will see that your screen will not come out. It will be just displaying that file continuously. So be careful when you issue a commands on a big file. Okay, so in the next class, if you guys are comfortable with the name node installation, we will clear some queries on the Hadoop installation. And the next class, what we do is we will show you how you can change the target cluster when issuing the commands. Generally, you will have more than one cluster. You will have a development cluster, you will have a QA cluster, you might also have a production cluster. How do you use different cluster from the same command line? That is number 1. Number 2, we will practice lots of Hadoop file system commands in the next class. Is that clear? But the prerequisite is going to be that you must install Hadoop and come ready. So then only you will be able to understand. Okay? Any questions in this class further? You can always mail us.
Can you send the installation doc?
Yes, we will send you the installation doc to Kathy. They will forward the same to you guys. So even if it is little trouble, I request all of you guys, for your own benefit, to make sure that you install it. Okay? In fact, we have installed this Hadoop cluster at least 12 times. So the more you install, the better it is for you guys, so that you know that when you take up a job, you will be able to do it much faster without thinking. You will do it with a lot of confidence. So anyway, so one more thing, Santosh, you can explain about the MapReduce browser file. I forgot about that.
Yes.
Yeah. Okay, so next class we will do that. Okay, next class we will do that. So let's not worry about the MapReduce part of it. We will only worry about the storage part of it for now. We will discuss all the storage. Once you guys are very hands-on with the storage, we will move to the MapReduce part. Okay, so the compute part of the cluster. So far we have been discussing about the storage part, how the files are stored, where are they, how they are replicated, which data node, how many blocks, where is the information about the file. All these things we have discussed. So it will be one more class on Hadoop file system. We will discuss these parameters in a very big detail, in a lot more depth. We will at least go over 15 to 20 parameters of Hadoop file system and how we are going to tune the file system for different purposes. We will discuss that also. So we will touch upon this. So don't worry, you will be bombarded with the same information again and again. The purpose is not to kill time. The purpose is to make sure you understand the concepts very clearly and be more confident. Okay. So when we discuss the MapReduce, we'll discuss the word count program again. Okay, so Santosh is going to just 2 minutes walk through the MapReduce part of it. So you can, when you install it, you should be able to go through this browser and you type in localhost:50030. You should see this particular browser page. and you would see that the state is running, what is the version and when it was compiled. And then if you come down further, it will say the cluster summary. It says it is running 0 map tasks, 0 reduced tasks, there are no submissions, and it has one node. Right? It has one node. So if you click on that node, if you click on one there, you will see the information about this node where the task tracker is running. Okay, the task tracker. I don't know whether Ashok did Ashok talk about task tracker and job trackers? That's a question for you guys. Did Ashok talk about task trackers and job trackers?
Yes.
Yes. Okay, good. So you can see that this task tracker is 1, currently running 0. The maximum map tasks are 2, the reduced tasks are 2, and there are other information which is there are no failures and things like that. So when we discuss in detail the map reduce configuration for an administrator, you would be worried, you would be doing more of how many map maximum tasks are there, how many maximum reduced tasks are there. We will also discuss how we are going to schedule a job. When a job is submitted, which task tracker the job is going to run on, which map task it is going to use. Are there any schedulers? If 2 people submit jobs and if the cluster is busy, how that job is going to get queued or prioritized. So we will discuss 3 different schedulers, and then how do we configure those 3 different schedulers we will discuss in the subsequent classes. Okay, so as an administrator you would be worried about primarily 4 to 5 things, right? Storage management, the compute management, the resource scheduling, right, and the name node high availability, and of course the performance. So we will touch upon these topics as we move forward. So prepare for tomorrow's class where Santosh is going to run through various different file system commands so that you guys will just be hands-on and become more comfortable with file system. So do not hesitate to type in whatever you want to try out. If suppose something gets corrupted, just remove the whole Hadoop directory, reinstall again and try it again. That's the only way you will learn. If you think that something is going to happen to your machine, then you will not learn. So I would suggest that install it multiple times, try these commands multiple times, and don't hesitate to type in whatever command that you want to try. Okay? So we will give you next week a list of all commands that you would be trying on your cluster and the expected outputs. That's all folks for today. Thank you. We'll see you tomorrow.
Thank you, Rudy.
Okay, bye.
Thank you.